Our discussion today is about section 4.2, amplitude and period. We're going to look at how these things are affected by the differences in the equations, and we're going to learn how to graph using those things using a systematic approach and also using a little bit easier approach at the end. Okay, so let's start. In our first example, we're looking to sketch the graph of y equals 2 sine x. In our previous video, we learned how to sketch the graph using the table. So what I've done here is I've used those 5 key values that I was telling you about in the previous video to kind of set the stage. Okay, once again, I'm picking easy values. So you'll notice that I've got in here x. Okay, so I'm going to pick natural values that would help me. So if y equals 2 sine of 0, when I end up doing that actual function, I get that that's equal to 0, so my ordered pair is going to be 0, 0, so my sine graph is going to start at 0. Makes sense. So y equals 2 sine of pi over 2, and at pi over 2, that's going to be 2 times 1, which is equal to 2, so we're going to have pi over 2, comma 0. When I go to pi, I get y equals 2 sine of pi, which is going to be 2 times 0, which is equal to 0. So I have pi and 0. I made a little bit of a mistake up here. Let me correct this real quick. My y is not going to be 0 up here. My y is actually going to be 2, which is what I found right there. Okay, so then I've got 3 pi over 2. So y is equal to 2 sine of 3 pi over 2. And once again, remember, I'm getting these values here. Sine of 3 pi over 2, that's in our coordinate plane. Okay, that's on our unit circle. And so I end up with 2 sine of 3 pi over 2 is negative 1. So I get that that's negative 2. So at 3 pi over 2, that's my negative 2 there. We've got 2 pi in here. Trying to get ahead of myself. So I've got 2 sine of 2 pi would be 0. So that's equal to 0. So I've got 2 pi comma 0. Now, when I go down to my graph, here's the big difference. When we look back up at our chart, we notice that our biggest values and our lowest values, so our biggest and our smallest, have changed now. They're not negative 1 anymore. So our highest value is actually going to be 2, and our lowest is going to be negative 2. Let's see where these happen. I'm going to plot this curve in red. So my first point is 0, 0. It's here. And at pi over 2, we'll notice that we make it all the way up to our maximum. When I get to pi, I'm at 0 again. When I'm at 3 pi over 2, I'm at negative 2. So I'm all the way down at my minimum. And at 2 pi, I'm at 0. So let's look at how this affected the graph. When I connect the dots here, notice what happened. The curve looks the same, but the big difference is that the amplitude has changed. I might have given it away. So instead of being 1 here, this is actually 2. Okay? This distance here is now 2 instead of 1. Let's go down to the next example. Sketch one complete cycle of y equals 1/2 of the cosine of x. So let's go ahead and solve this problem. Y equals 1/2 cosine of 0. So the cosine of 0 is going to give us 1. So it's 1/2 of 1. So my ordered pair is going to be 0, comma 1/2. When I put in pi over 2, I'm looking to my unit circle to get this cosine of pi over 2. So I've got 1/2 of 0, which is equal to 0. So it's pi over 2, comma 0. Y equals 1/2 cosine of pi. Looking to my unit circle, I have 1/2 of negative 1. So my ordered pair is pi, comma negative 1/2. y equals 1/2 cosine of 3 pi over 2. Once again, looking to my unit circle, I get that that's 0. So it's 1/2 of 0. So 3 pi over 2, comma 0. And y equals 1/2 cosine of 2 pi. 2 pi, just 2 pi, not 2 pi over anything. Okay, and so when I take the cosine of 2 pi, I get 1. So that's going to be 1/2 times 1. Okay, got my points once again. So when I plot this, I'm going to put in my significant values once again. Pi over 2, pi, 3 pi over 2, and 2 pi. This is 0, obviously. So when I put in my values, I know I'm going to start at 0, comma 1/2. Well, let's look at where that is. Here's 1/2 here, and here's negative 1/2. So I'm going to start here. When I get to pi over 2, I'm at 0. When I get to pi, I'm at my negative value, so I'm down here. And I'm going to continue up this way, plotting my curve, using my points. Now, the differences. Highest value. Is 1/2, not 1. Lowest equals negative 1/2, not negative 1. So the difference is that my highs and my lows change based on what number's out front. Remember that. Okay? Let's look at another little example here. Here, the 2, the coefficient, is inside of the parentheses, so we're going to look at how that affects our overall goings on here. So let's look at 1/2 cosine of x. If I look at the cosine of 0, I know that this is y equals 1/2 I confused myself because this is not our function. Our function's up here. So we've got y equals sine of 2 times 0, which is sine of 0, which gives us 0. So my first point is 0, 0. And I'm going to continue down this way. So y equals sine of 2 times pi over 4. Now this is where we're going to start using these fraction operations, guys. We got to know our fractions. So this is really going to be pi over 2, which conveniently, look, it happens that it's on the unit circle. So when I have that, I get 1. So my next point is pi over 4, comma 1. So y is going to equal sine of 2 times pi over 2 is the sine of pi, which is going to be equal to 0. And you'll start to see kind of how this works. The biggest part of this one, guys, is the fraction operations. Okay? This is going to be the sine of 6 pi over 4, which is really going to be 3 pi over 2. So that's going to give us negative 1. See, even I'm checking my unit circle over here. Okay? So this is going to be y equals sine of 2 times pi, which we know is 2 pi, which we also know is 0, so it's going to be pi, comma 0. Okay? 5 pi over 4 is going to end up being y equals 10 pi over 4. I'm abbreviating now, guys, because you kind of see how this works. When we multiply these out, we end up getting these fractions as something different. So 5 pi over 4 is going to be 10 pi over 4, which we know is 2.5 pi. So this is going to be the sine of pi over 2, which is going to give us, excuse me, 5 pi over 4, comma 1. Okay? And moving down the line, we get 6 pi over 2, which we know is 3 pi, which would be coterminal. A coterminal angle for this, 3 pi, so we'd go, here's our circle. So if we go all the way around, that's 2 pi. Then we go halfway around. So this one's going to be equal to sine of pi, because it's coterminal with it. And the sine of pi is going to give us 0. So we have 3 pi over 2, comma 0. 7 pi over 4. Is equal to sine of 7 pi over 2, which we know is 3.5 pi's. Okay, so if we have 3.5 pi's, we go here and then another half, so we'd be down in this area here. So we know that's going to give us -1, so we have 7 pi over 4, comma, -1. And sine of 2 pi going to be the sine of 4 pi, which is 2 times all the way around, which is going to be 0. So 2 pi, comma 0. Okay? Same process here, guys. I'm plotting this out. And so this time, my graph is actually going to have more points that I'm plotting because I've got pi over 4, pi over 2, 3 pi over 4, pi. 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi. Let's look at these actual points that we're plotting. I'm going to be scrolling up and down. So we start at 0, 0, and we're oscillating between 1 and -1. So I'm going to pi over 4, 1. So here's 1, and here's -1. When I get to pi over 2, I'm at 0. When I get to 3 pi over 4, I'm at -1. When I get to pi, I'm back at 0. When I'm at 5 pi over 4, I'm at 1. When I'm at 3 pi over 2, I'm at 0. 7 pi over 4, I'm at -1. And 2 pi, I'm back at 0. Normally, the 2 pi, we only get one of these curves in. But because of the way this graph is, the difference is we get 2 cycles So we get 2 cycles for every 2 pi. So the period has changed. The period is half of what it was. Okay? So, in general findings, if we have equations here, y equals sine of x, and y equals sine of 2x. Okay? We have number of cycles per 2 pi. This was 1. Now this was 2. So the period was 2 pi. The period here was pi. So in general, if we have y is equal to sine of b times x, the number of cycles is going to be b. So it's going to be 2 pi over b is going to give us how many cycles per pi we get. Okay? Now let's skip down. So in general, let's look at what this means. So this means that if b is a positive number, the graphs of y equals a sine bx and a cosine bx have an amplitude of the absolute value of a. So that's how high and low. The max and mins move. Okay, they also have a period of 2 pi over b. So it's the normal period over the b, which is our change, and that's going to give you how long it takes to go through one cycle. Okay? Thanks for watching, guys. That's amplitude and period. We'll talk about it more in class. Thanks for watching.